This is the mission 58, organized by Space Analog Station, Habitat Marte. Today is November 28th, 2020, and we will have the presentation of Aravind Karthik. Okay, Aravind will be talking about the Engineering Center. Okay, Aravind, thanks so much for your contribution. Just a moment.
Yes. Um, Hi guys. I am Aravind, aerospace student from India. Welcome to Mission 58 organized by Habitat Marte. I was actually a previous participant from Mission 56 organized by Habitat Marte, and I was the representative for Engineering Center. For aiding this mission as well, just to give you an intuitive feel as to what exactly Engineering Center is and what are the stuff that goes behind setting up a proper functioning habitat in Martian atmosphere. So let's delve into deep into it, guys. Yeah, and spoiler alert. Before, Mars has always been the inspiration for all the scientists and pop culture directors, and even kids, for example, Elon Musk, etc. So I'll be using a lot of pop culture reference in here. Yeah, interstellar, aliens, maybe, perhaps, Martians, etc. So bear with me, guys, and this presentation is going to be loaded with hell out of it. Basically, in my presentation, I'll be covering, first of all, what exactly Mars, why are we willing to go to Mars in the first place? What is the performance of the Mars in terms of how it is going to assist when we build engineering settlements over there? And what is the internal design which goes along with it? Finally, the technologies which are mandate to be used over there to tap the maximum potential out of that surface, and the organizational structure, followed by which rations and the psychological assistance. Psychology is something that's quite important over here because when it comes to astronauts are staying in the Martian Martian lands, distant lands for a really long period of time, it becomes really mandate that their psychology is balanced. And as you guys might very well be knowing, with a launch window of just about 2 years from Earth, and it is very difficult, and it is very an immediate necessity that astronaut psychology must be. Finally, every station, whenever it is established over there, should run with some certain protocols and guidelines and protocols established over that particular, especially I'll be scrutinizing over engineering center aspect. So only pertaining to that place, what are the guidelines and protocols that are to be used? We'll discuss about it. So, how did it all start? We were back in those days, back in 18th and 19th century, we were flight fanatics. We were crazy about, getting just airborne. But how getting spaceborne all started? Well, from what started as just a Cold War between America and Russia, getting to the space was considered as a winning point for the Cold War. Russia launched the Sputnik, and US tried really hard using their infamous Kaputnik, as you can say that, which failed really bad. It all started just like that, and it was mere competency between these two technologically dominant countries to get an edge over their peers. So that's how it started. But now the face of space exploration has really changed. We are more interested in exploring and understanding the very existence of us, and thus determine how the planets originated and how it all started. Well, we are not ancient Greeks to put all the answers over gods, but yes, finding science is one of the major answer, and finding a few unanswered questions. So that also really helps. So, potential transformation of humanity. This place has always been the speculative for fiction, be it Martian movies or any other movies for that matter. This has always been the place for scrutinization. A very well writer by the name Scott Solomon, he's a biologist from Rice University. He wrote a very stellar book about how we might evolve in the future. What are the future prospects of humans with all the technologies we possess, and how we are going to utilize the technological implementations, I would say. So, as Darwin really says, survival of the fittest is very necessary. Yes, but for evolutionary change to occur, we first need genetic variation, and thus we need natural selection. It's not that all of people, all the species from Earth can go to Mars. It's only the technologically adept, or rather, we could say, uh, the best among all the species in planet Earth can go to the planet Mars. Why is it so? It's because we technologically ahead. So one of the primary concerns over here are environmental pressures, and there are several other psychological effects which comes into picture. So according to a documentation by NASA, we can go to space. Yeah, man, come on. Space is always has always intrigued mankind, but there are few severe backlogs or severe problems which needs to be resolved before we can sustain or rather thrive in space. So space radiation is one of the really important aspects. Our Earth is surrounded by a blanket of thick atmosphere, which is really good at blanketing or shielding out most of the radiations which are incident on planet Earth because of its rich atmosphere. Yeah, well, it's secondary that we are ruining that atmosphere as well. But yes, for now at least, Earth's atmosphere plays a really key role. Then isolation and confinement. We uh, we have very well experienced. I guess people from India could relate to this more. COVID-19 lockdown. It's been going on for several stages right now, and we all know how we have been psychologically affected without seeing the place we go regularly, without interacting with our friends, separating distances. So just for separating by few kilometers, we are concerned. And when this comes, isolation for astronauts really matters. Gravity is another issue, and because the bone doesn't have much work to resist against the gravitational force, which is found just like in that of planet Earth, the bone density eventually reduces. Osteoporosis comes into picture, and astronauts become really weak. So health is also an important thing. Finally, hostile environments. Well, if we are going to Mars, we just can't predict. As of now, we just have robotic arms or rovers working on the planet of Mars. But we just can't understand as to what exactly the situation of Mars is. So all these concerns are something that needs to be addressed. Okay, fine. We have been speaking about Moon and Mars for a really long time. But what exactly was the starting point for all this interest? Well, started right from the age of Greek, where they considered Mars, they saw a red glowing planet on the sky, and they considered it to be a sign of God, God of war. And eventually, several inspirations from pop culture, such as War of Worlds by H.G. Wells, wherein Martian aliens coming into Earth and invading them. So these were all the inspirations for Mars initially. But then eventually our understanding over the planet Mars and our interest, rather, we could say, that eventually grew. And Schiaparelli is a famous astronomer. By means of his observatory, he observed the planet of Mars and he observed several canals. Earlier, he thought that these canals were actually the residing places of intelligent life. Keyword is intelligent. Intelligent life staying along the canals. However, eventually it turned out to be these canals were actually formed by millions of years of water eroding the surface and finally getting evaporated. And finally, the first step was just a minute. Finally, the first step towards exploration was the Mariner 4 spacecrafts, which performed the first successful flyby of Mars, taking large amount of pictures. As you guys might be very well aware of, you guys might be more interested in space than I am. Every mission starts with first a flyby and then an orbiter, followed by which, if the planet is found to be potential, then they go ahead with rovers, etc. So this Martian surface pictures by Mariner 4 really intrigued mankind, which stipulated the interest to go towards Mars. And there is a famous saying from NASA, which was started back in 2018: Moon to Mars. Moon is considered to be the gateway. Well, why can't we directly reach Mars in first place? What are the technical implications that goes behind it? Martian surface is, of course, said to be holding a lot of water, especially in its polar caps. But why exactly are we not able to go to Mars straight away, and what are the implications that comes behind it? Firstly, you can go to Mars only every 2 years. The launch window for reaching Mars is very narrow, so that there can't be frequent missions which you can go to Mars, such that you can go to Moon. So Moon is considered to be just like a gas station for reaching Mars. That is the reason we are marching towards first colonizing Moon, setting up a base on Moon, and eventually going out to Mars. Speaking about the geographical features of Martian surface. It is a dry world. It was once water rich. As you can see towards the right side, the picture specified. It was once water rich with canals 100 times greater than that of Arizona, wherein water was full flowing. But now, because of the rapid changes in the Martian atmosphere and the thinning out of the atmosphere by the impact of sun's gravitational pull, eventually it became waterless. So the conjunction class Mars, there was an efficiency, energy efficiency launching from Earth when two planets are aligned. So this is called as conjunction class missions, wherein, as you can see over here, the Earth, Moon, and Mars lie along the same line, so that the launching will be very efficient in terms of energy. If Moon not be present in this case, then the launching would have caused excessive energy, and the pollution that comes with it, as well as the technological requirements which comes with it, will be very huge. So Mars does have quakes, and it does have all the natural phenomena which we have in planet Earth. But there is just one slight advantage. In a planet Earth, the entire surface is scattered into several fragments called as tectonic plates, as you guys might be aware of. Whereas in the case of Mars, the situation is totally different. Even before the entire structure could collapse into several tectonic plates, the magnetic field on planet Mars ceased. It is very low in strength, we could rather put it that way. So because of which the entire surface is just one single mold of rock, just like a ceramic. It's a mold of rock. So you don't have dangers of quakes. So in first place, why are we understanding Mars? Because understanding Mars and the problems that comes with it helps us build a better engineering solution. People from engineering background could relate more to it. Problem comes beforehand the solution, and if we have a proper understanding of the problem, then solution could be very well drafted. So these are all the understandings that goes behind constructing an engineering center in Mars. So since Mars clouds can reach about 3,000 feet in height and can last for several weeks, the Martial cyclones and dust storms. So this indeed is quite intense. And because it's made up of one single entity, there will be less chances of quakes, but also there will be less spinning because of less magnetization. And the inner core is almost solid. It's not like that of Earth, not hot or magma, which you find over there. It's almost cold and solid, because of which the spinning and thus the resistance to radiation is very low. These are few data. So you guys can ask me, why not other planets? Why not some planets? Saturn's moon Enceladus is quite rich in biomolecules. Why can't we go there? It its entire surface is filled with water, and potentially we could tap energy out of it. Why not Deimos or Phobos, moons of Mars? Why only Mars? The thing is, we just can't get used to sudden changes. The Martian day, the Mars diameter of the Mars, everything is almost equal to that of the Earth, which places us in a better situation as compared to that of other planets. So that is the reason actually. And as you can see, Mars atmosphere is about 95.3% carbon dioxide with very small amount of other gases. With such extensive amount of carbon dioxide, tapping of energy or extracting ice from the colder Martian atmosphere is very really easy. But extracting oxygen out of it and further survivability is really a difficult challenge. So this is actually the launch window which I was talking about. So from here to here, usually it takes several rotations because the orbital speed of Mars and that of the Earth is quite different. So that it takes about 2 years of wait till we can launch the next mission to Mars from Earth. And provided that resources are really mandate for survival of Mars astronauts, at least during the initial setup of the colony. So it really is important. And next we speak about the Mars for engineering and industry. Well, if we have so much technology, we have technologically become so much adept, whereas we just can't rely on Martian atmosphere for all the necessities, right? Martian atmosphere as well as the Martian surface for all the necessities. Eventually, we might have to resort to whatever is available in situ, and thus we need to adapt as accordingly. So the surface of Mars is distributed with various minerals, but minerals which we have not used for construction or any other engineering purposes. So so for this purpose, the technology readiness level, we have to push it really forward to meet the demands. And when it comes about setting up some, a base, first of all, we have to decide upon where exactly we should place it. The entire surface is volcanoes and lava plains. So we just can't risk our money as well as lives for setting up with some, sporadic volcanic activity places. So for that, we have to select a proper appropriate place. So where can that be? The entire surface, as you can see in the next slide, the left picture is the northern hemisphere, and the right picture is bottom right is the southern hemisphere. Northern hemisphere is totally scattered with volcanic rocks, and by years of eruption or millions of years of eruptions, the surface is totally rugged, and it is just not suitable for establishing a proper leveled base. The regolith over there is really not suitable for tapping out the necessary resources from there in first place. But yeah, one advantage is that it's got large polar caps. Where we are planning to set up the engineering center, as well as where most of the rovers and landers are planning for launching, is mostly in the southern hemisphere. So this is because the southern hemisphere is relatively smooth. It's more like plains, or here you call it planitia. So this particular region is quite smooth, and it's got rich deposits of minerals, as well as potentially good source of frozen water beneath the surface. That is the reason we are opting for the southern hemisphere. People quite into geosciences could relate more to this map. This is a surface distribution of it, wherein we are mostly going to go for Hellas Planitia, or rather Iona Terra. So these two regions are the potential areas for establishing a zone, and tapping of all the water resources can be taken from the polar caps or even beneath the surface. So when it comes to extracting water from the surface, a rod well approach is something that's really useful. And guys, this is not a new technique. In fact, it's a tried and tested technique. People in Antarctica who stay years together for research, they usually get their water resources from methods such as this. It's nothing but drilling deep into the surface to melt a pool of frozen water, and then post which the cycle is established, and there will be a constant cycle of heating and cooling to get a pool of water eventually. So this is how it works. All right, guys, enough of geosciences. We have come here for engineering aspect, and let's dwell deep into the engineering aspect in first place. So just for the sake of this presentation, let me assume that I am the fictional engineering center chief. So what will be my responsibilities here? So my first responsibility will be for the maintenance and repair of the entire station. And it also involves maintaining and repairing of engineering equipments across the habitat. So unlike other centers, as Professor might have discussed earlier, we got a lot of centers which are potentially necessary for setting up a habitat, like health center, power station, etc. Everywhere engineering comes into picture. And when we are setting up an engineering center, and me as engineering center chief should take care of all the equipments which are scattered around the habitat. Finally, it would be to lead, govern, and participate active engineering supported researchers. We are going there not for living or for a, we are not going there for a tour. We are going there for scientific analysis. And when it comes to scientific analysis, collaborative research with other firms as well as engineering supported researchers must be done. And geospatial mapping is something that's really important. We also should develop new technologies, and till of course, Mars people could expect independence at some point of time, but until then, we have to communicate frequently about the happenings in the planet Mars, at least within the habitat, and thus frequent communication to the Earth base is also mandated. So despite setting up a workshop, which we find in conventional Indian colleges, it's also necessary that communication satellites and proper communication transmission modules, such as antenna with proper radio frequency settings, all these also should be governed by the engineering center. We also should promote collaborative research, and until standalone Marshall industry buds, we should meet the material needs. We just can't depend upon Earth. As I said earlier, it's 2 years of equipment. Say, for instance, in the middle of 6 months, all the resources are gone because of some calamity or some natural phenomena. We just can't wait for another 1.5 years for Earth to send resources to us. And even that, if that's possible, the success of the mission is again highly questionable. So we have to self-sustain once after we have reached there. So that's what the last point states about. So yes, finally we'll discuss about my proposed internal design. Actually, this design was proposed by me for Mission 56, and just for intuitive understanding of mission participants of, or rather analog astronauts of Mission 58. I would also like to share the concept which I designed. So this is the engineering center which was proposed by me. So unlike other simple Mars habitat which we find over there, we are going there not to survive, but actually to thrive as humans, and thus to sustain humanity. So a deep understanding of several features of Mars is really necessary. So my concept design is actually very sophisticated in terms of equipments, whereas it's very simplistic in terms of construction. It's sophisticated yet simplistic. So before I discuss about all the features of this of this engineering center in specific, let me give you a brief overview of what exactly it is. So the surface is built with in situ available materials, which is nothing but basalt reinforced polymer, and then it's got, the Martian dust is something which is really to be scrutinized. That's a matter of concern. So proper airlock and fumigation systems must be present over here. And this is basically a 3-4 establishment plus one radiation shielded observatory. And finally, for the sake of meeting energy requirements, at least to self-sustain this engineering center, I have included vertical axis wind turbines. I guess people might already be aware of vertical axis wind turbines. And for those who don't know, vertical axis wind turbine is basically a wind turbine, just like that of windmills which you find across the country. However, the axis of rotation for conventional horizontal axis wind turbine will be this way. It will be along the plane of my palm. Whereas for vertical axis wind turbine, it will be along the plane of my thumb. The rotational axis will be this way. So that's what is the difference between a horizontal axis and a vertical axis wind turbine. I'll be discussing more about it when I speak about the power station requirements of this particular settlement. So basically, just yeah, all of you guys might be aware of. So we have to solve all the problems which astronauts will be facing when they are away from planet Earth, far from their families, far from materials, ease of availability. It's just like starting right from scratch, starting from Stone Age. So we have to make sure that all the facilities are available. So my design is actually a settlement of 3 floors, wherein each floor has a specific purpose. The first floor is actually meant for frequent visits by other habitat people, and also for training from engineering aspect. People from other settlements could come to my particular base for training aspects from engineering perspective, be it 3D printing in terms of manufacturing or any other technological improvements. It's also got a garage wherein all the rovers and all the engineering equipments, exploratory vehicles, we could say, all those will be stored with vertical parking system, and it is also the place for potential repairing. The second floor is somewhat isolated, and this is only accessible to people pertaining to engineering center in specific, or rather level 3 access. So key researchers pertaining to engineering center alone, and their administration, there will be boardrooms for administration. There will also be control rooms. And the final floor, the top floor, is actually meant for astronauts, astronauts working there, and for them to just relax and spend their day. So this entire the top floor is basically scattered with gymnasium and an ambient resting place, and also several other entertainment features. So when we are speaking about habitat, the following parameters must definitely be taken into consideration. This is not just for engineering center habitat, but all the habitats in specific, the radiation and dust shielding is something that's really important. The first thing is radiation and dust shielding. We have to check about to what extent the surface of the planet can resist the radiation, and post which we have to design appropriately. The next thing is material availability. uh, we just can't, as I said earlier, we can't depend upon Earth for all the resources, and we have to construct something which is readily available on the Martian surface. So the time to construct is also something that's important. And finally, we speak about the cost of construction, the maintenance, and the ease of deployment. If there is a habitat which takes years to construct, then it's futile. It turns out to be futile. But we have to see that for accommodating the astronauts as soon as possible and to tap the maximum potential out of the surface, it should be easily deployed and it should also be pocket friendly. So this is the basis of my construction, and this is something that's common for all the Martian settlements. The surface, even though the chances of quakes is quite low because of the molten core reason which I already gave, it's still mandated that the surface is quite broader, such that the center of gravity is quite below, so that there won't be any effects of toppling when some unprecedented things happen, such as Martian storms, etc. If you guys followed Habitat Marte's YouTube channel previously, several people in the due course of mission, you guys are in mission 58 actually, but several other missions, people suggested a whole lot of ideas for a potential Martian survivor. But I don't completely agree with it. The reason is, if we are going to just do a normal research, it's fine. But since we are going to thrive over there, ambience is something that's really important. There is no point in building underground bunkers or shielding the entire surface with mud and giving it a reason for saying that we need to protect it from radiation shielding. No, that's absolutely not necessary. With advancements in material sciences and radiation attenuation technologies, we could build both ambient, self-sustaining, as well as very cool-looking habitats for astronauts to stay. Uh, it's really difficult to stay in a place without any windows, without any kind of ventilation. So several other designs with windows and with ambience were proposed by NASA design contestants as well. And the top picture which you see is one of the suggestions and one of the winners, I suppose. So these designs must actually adapt to withstand the pressure, radiation, and temperature extremes of Martian surface. So the surface is really hostile. It's something that we need to agree that despite our interest to go to planet Mars, we have to bear with all these conditions to actually set up a proper habitat. So our habitat should actually be pressure resistant. It should not have all those sharp edges or other sharp corners, so that it will exert pressure over the corners. People from mechanical engineering background could relate more to it, because pressure concentration over the corners will be more, which eventually leads to structural failure. And temperature extremes is also, it's something that is to be considered. Martian surface rates extremely low temperatures during the night and extremely high temperatures during the day. Well, high temperature is, you may argue that, well, it is separated from quite some distance from planet Sun, but it's because of the radiation retention of the surface that causes its temperature to rise, especially along the equator side. So as I was saying, the material which is suitable for the purpose of building is actually basalt fiber reinforced plastic composite. So this is basically a translucent kind of material. It could allow natural sunlight whilst also protecting us from potential hazards of radiation. And my design actually has the roof covered with 1.5 meters layer of water, and it's got a low pressure layer about it. So there is some layer separation that provides necessary radiation shielding. It also allows natural lighting. So here's my design. My design actually, the bottom floor has about 5 features, wherein to the right you find the manufacturing division. I'm sorry, to the left you find the manufacturing division, and you find training department, which I was speaking earlier, where all the astronauts or literally anyone who wish to learn, there will be computers as well as virtual reality headsets present over here with necessary resources already loaded into the computer. They could come here, train themselves for potential future missions. The third region will be repair and maintenance division. Say, for instance, if in the health center there is some, operating equipment which is repaired, then based upon some successive norms, as in like booking tickets or rather complaints via a virtual local server which is placed over there for the entire operation of the habitat, consecutively depending upon the order of booking the tickets or rather complaints, they could get their products repaired. So the fourth is a depressurized smart garage. Well, what makes this garage smart? I'll be coming in the next in the consecutive slides. I'll be explaining about it. And finally, you have access to the central stairway. But space management is really important in habitats such as this. And when it comes to transportation of equipments as well as for people, we have to offer a redundancy for transportation. So for the sake of the be a forklift, which you find in construction sites, the cascading lift kind of mechanism. So it's got a central access to all the floors, and for transporting equipments as well as for transporting people, this lift as well as staircase will be a very useful means. And speaking about the dimensions of the entire engineering center, basically its bottom diameter is 8 meters and constructively it reduces as we go to the top floor. Why are we considering specifically 8 meters? Because the reason is there will be launch vehicles and such as Falcon 9 and other Starships potential high payload carriers. So for those cases, the diameter of the payload section is actually 10 meters, and 8 meters will be a fairly better threshold for repair and for accommodating the entire cascading engineering center. So the role of repair and maintenance division is basically timely repair and periodic maintenance of all the engineering instruments, and it also deals with micro to medium-sized engineering equipment maintenance. Why specifically micro to medium is because we just can't transport because all the equipments and get it repaired over there because of the space constraint. What could be a potential future prospect is that setting an outpost wherein the testing of all the newly developed engineering equipments as well as maintenance of heavy equipments, engineering materials will be done over that particular region. So, as I said earlier, there will be server rooms as well as potentially locally hosted web servers along the entire habitat, through which all the communications, be it communications across the habitat or even maintenance complaint registration, everything will be done across that common web server. So this is my idea basically, and implementation of this greatly eases the management of the entire habitat. So considering the minimal space utilization, we just can't use heavy equipments. So R&M division will incorporate two separations. R&M is this region, the repair and maintenance division, region 3, which I was talking about. So R&M division, of course, will be having electronic components repair as well as mechanical components repair. Electronic components repair requires the room to be clean because of the potential dust logging which could come into the electronic equipments, because of which there will be two separate clean room divisions. Accordingly, the management of all the repair and maintenance will also be done. And when we speak about the manufacturing division, well, a most common manufacturing, two common methods of manufacturing is additive manufacturing and subtractive manufacturing. The entire world these days is going towards and it's gearing towards additive manufacturing technology. And well, it's quite obvious why, because with we have the designs in hand, we have the potential to create designs, and with advancements in material sciences and all the nozzle flow technologies, 3D printing could be lucidly achieved. It could be achieved in a seamless way. So all the micro and macro product needs can be done by 3D printers basically. If I need a set of forceps, or if I need even a spoon, I could get it printed in these 3D printing production center, manufacturing division. Again, it follows a sequential placing orders and then getting the product finally. However, not all products are going to be entirely based on 3D printing. We just can't rely on plastics for all the cases. And since we have to deal with all the vary temperature changes, it becomes really mandate for us to also have some potential metal or metal analogous material manufacturing systems as well. For that reason, this area also houses a portable CNC as well as a laser sintering machine. Well, what 3D printer does for plastics, laser sintering machine does for metals. You'll be having powdered metals, wherein by means of laser sintering over the particular surface, you could actually generate the necessary intricate metal objects, which is not possible with conventional manufacturing methods. Conventional manufacturing methods would have otherwise taken acres of establishment for a proper functioning industry, but this doesn't really need that. And the training center. Um, it's not like, because these days we are gearing towards collaborative research in all the aspects. An engineer should also know about the happenings of medical science for him to suggest a appropriate solution for medical science in first place. So collaboration is something that's really important, and my engineering center solution considers that as a top priority. So training will be open from 9 to 5, and it is potentially available to all the astronauts with a level 2 access basically. So with level 2 access, these astronauts can get to the engineering center, and by means of VR headsets and potential systems, they could learn. And what is the other advantage of here is, of course, you all guys may be aware that CAD model is something that's really mandated for production in first place, especially for 3D printing, because you need to splice it in eventually, and stereolithography model is quite important. So for that purpose, what we are basically going to do is, um, we'll be also giving the opportunity for the astronauts to design 3D models over there. And these 3D models, upon proper validation by the engineering center chief, here it's me. So upon validation, actually you could get that particular product printed, or you can elevate it to manufacturing phase as well. And yes, I've said like it's depressurized smart garage. So what makes this garage actually smart? Well, see, can you guys, if you can discuss, can you guys just state few of the exploratory vehicles which we use on planet Mars, both manned and unmanned? Can anyone say? Just one of you.
Yes, it's a interesting concept. I imagine, uh, Aravind. Uh, it's something that also you like to think about the garages, as how to keep the vehicle safe, no, and also because I imagine that the Mars will be happening a lot of dust, and then we need to think how the dust will be bring some damages to the vehicles, okay, and then I believe it's very interesting. We'll be talking also about the garage, because our garages
Yes, sir.
would be a good element to protect the cars and also the mechanical, because I believe it will be not easy to think about how to keep these vehicles safe. Some
Yes.
some of my comments.
So what I actually meant was, there are a varied range of exploratory vehicles. Actually, you have rovers which are both manned and unmanned in first place. You have rovers which are unmanned, and for manned, you have space exploration vehicles, which is a really sophisticated and pressure shielded exploratory vehicle. When it comes to housing, they are of varied dimensions. When it comes to housing them in the particular garage, with provided that we have a very small space, it becomes really challenging. So to the left, you can actually see this is something which is really common in metropolitan cities. So in those cities, you have this vertical parking. So the astronaut basically will have access. The astronaut basically will still have access to the entire garage. By means of touch interface, he actually selects the particular vehicle which he needs, be it for exploration or be it autonomous. He selects it via the pressurized chamber, and when he comes out of the engineering center, by means of this vertical lifting, just the particular exploratory vehicle which is necessary for his mission will be deployed out. So this is the entire thing that goes behind the smart garage system. So by this way, we could reduce the possible dust infection. And dust infection is just not confined for asthma patients, but it's also something that's mandated. Why? Because the Martian surface is dusty, yes, but it is rich in radiation. We just can't potentially get radiated by harmful radiations. And to protect ourselves from the harmful dust, this is a really important solution. And this is the floor 2 plan. Floor 2 has server and supercomputer room. When it comes to engineering simulations, it takes a very high computing power to actually meet all the engineering requirements. So the particular room in the second floor is actually dedicated for server as well as for supercomputer. A server is for basically storing, as I said, the website which will be locally hosted. It's used for that purpose, and the supercomputer is actually used for solving complex problems. The restroom, yeah, that's quite mandate. Every human needs that. And third one is R&D alpha, and fifth one is R&D beta. So there will be two divisions, and pertaining to core engineering research and non-core engineering research, these alpha and beta is basically scattered just to organize the potential research. We need not mix up things. And the fourth region is actually the left, which I spoke about. And sixth is broadcast center. Well, we have to know about Martian news, and there must be some people who are broadcasting the news. Here, this particular room will be noise resilient, and it will be shielded with acoustic materials so that it will be suitable for broadcast. There will be a particular radio frequency which will be set for transmission within the Martian habitat and for transmission from Mars base to planet Earth. So two different ranges of frequencies will be set, and appropriately bandwidth, you could say, and appropriately the transmission of radios will be done. Seventh is the control center. This is one of the major aspects. Main station also shares a part of this work, but from engineering aspect, the control and communication center is basically and predominantly concentrated for communicating with the Earth base as well as for monitoring the deployed vehicles. What I'm personally thinking of is we have rovers, and with potential advancements in aerodynamics and aeronautical research, drone deployment and rotor dynamics is also possible along the Martian surface. So monitoring of all those autonomous equipments as well as for manned mission will be done in this control center. As I was speaking, right now, I guess we are in the due process of sending drones to Martian surface for exploring the Martian lands and as well as identifying potential resources. Rather than being in a rover, when we are airborne, it greatly increases the efficiency as well as reduces the time that is necessary for exploration. So there is a popular technology called photogrammetry, as you guys might be aware of. So by means of several photos which are taken along the Martian surface and by means of lens calculations, there will be a digital model which will be simulated about the Martian surface. So this helps us very clearly understand about the resource distribution and the potential spots for future habitats as well. So rather than using a single drone, we could use swarm of drones which intelligently interacts by means of Internet of Things. By means of that particular technology, it could interact, and later it could split up the work and generate a virtual map of the entire Martian surface. So this equipment will be stored along the edge of the second floor, so that the swarm of drones could be deployed upon request by the control center. Floor 3 is just for recreation and for ambience. You will be having gymnasium, and gymnasium is not a sign of luxury, but rather it's a sign of maintaining the health of astronauts, because Mars gravity is just about 38% as compared to that of the Earth. We just our bones, because evolution has always been selective, and unwanted strengths or body parts are removed then and there as and when the evolution progresses. So if at all, if astronauts are used to this 38% of gravity, the bone density and eventually the strength of astronaut drops, who are actually, in the due course of time, post completion of research, they are due to return to the Earth. So gymnasium actually helps in especially high intensity training for about 55 minutes, which is a standard set by NASA. So all the high intensity equipments will be stored over here. Fourth is meant for storage. 2 years is a really high time. The storage is actually present in all the habitats for potential storage of rations. And fifth is kitchen, sixth is filtration and HVAC chamber. The Martian surface is dusty, as I already said, and carbon rich. But here we are maintaining a pressurized condition. So for maintaining a pressurized condition, there will be constant circulation of air, wherein we have the filtration systems, the air filtration systems, and ventilation systems, heat and ventilation systems plays a key role. The seventh will be dormitory. This entire region will be dormitory, and there will be restrooms on either sides for aiding customers. So why specifically am I taking filtration chamber and HVAC systems? Well, this particular technology has been under research for almost several decades, I could say, right from the maturation of a refrigeration system and proper thermodynamic cycle establishment. Proper filtration systems and ventilation system has always been the area of scrutinization. But here, when we are going to Mars, since we have potentially low amount of resources as we find on Earth, and even the technology to extract resources is also not going to be. So for that reason, we have to find something that's easily replaceable as well as durable. For that reason, there is I came across a paper. As you can see over here, I've added the references. There is a paper which I came across, and it was really intuitive. It was actually filed by IRX Co Limited from Taiwan. So what they proposed us was an absorbent which is based on coconut granular structure, and it is shielded with a thick layer of activated carbon. So this non-woven fabric has actually had potential and very useful radiation attenuation systems, as well as for filtration chambers and HVAC systems. So it solves a dual purpose, because of which it can be used as it's a good candidate for utilization. Yes, as I've already specified, vertical axis wind turbine. So this vertical axis wind turbine, as you can see over here, you can identify potentially what's going to be the axis of rotation for this particular blades. Well, what is the advantage in first place is that all the equipments, yawing mechanisms and all the mechanisms which are conventionally found near the blades of the wind turbines, it could be hosted in the ground region itself. It doesn't need any kind of sophistication, because it's relatively simple and easy to operate. Because of its seamless structure, it occupies very little space. What a single horizontal axis wind turbine takes, four vertical axis wind turbines can be placed in that particular location, which results in extensive space utilization. And yes, a few of you guys could argue, well, we don't have proper sunlight in Martian surface. We don't even have a good atmosphere, because the atmosphere is thin. That's the reason we are facing with radiations, right? So what's the use of tapping solar and wind energy here? Well, nuclear energy is in fact going to be the predominant source of energy. However, nuclear energy could be lethal as well. So these sources of energy, especially as I said, Martian storms could reach about 3,000 feet or so. These sources of energy could be like a redundant system for power station. Always adding redundancy helps in a better power management and reduction of the loads over the entire habitat, and this solves the purpose. The power generated here is basically, well, power station is actually an entirely new concept, which is a separate section in Habitat Marte. But whereas when it comes to this particular vertical axis wind turbine settlement, the entire power which is generated over here will be connected to the common grid. So that common grid will be necessary for distributing power across the entire habitat. And few of you guys, if you have some a real interest in exploring the aerodynamics of wind turbines, this is a really good potential research area, and people are researching a lot into it. And there are several other designs. This particular design is called as Darius vertical axis wind turbine, with all those cams and twists in the blade. But there are several other designs, and this is an amazing field of research. Now, enough of technical side. Even in fact, I haven't listened to my lecturers this long. So technical side, I think that's about it. Now let's get to the administration side. Well, humans are always good at suggesting technologies, but when it comes to implementation, it is a really challenging aspect. So it's organizational structure. Basically, the more the manpower, the more efficiently we could manage the work, but provided that the payload restrictions as well as the training period of astronauts. Once NASA selects astronauts, not even in a definite amount of time. Whenever it has potential vacancies, it selects astronauts, and ISRO has not even started selecting astronauts in first place. So, with very minimalistic vacancies for astronauts and the intensive training and the intensive funding that goes behind it, manpower, we have to keep with minimalistic astronauts how efficient we could manage the entire structure. That's quite important. So there will be one engineering center chief, that's me, and excuse me. There will be one engineering center chief, and there will be a habitat technician. Where engineering center chief is basically the monarchical person. I'm just exaggerating the power of him. Basically, he is responsible for all the decisions which will be taken in the engineering center and all the associated engineering decisions. Habitat technician is something who's next level to the engineering center chief, and he deals with proper, connection between the different departments within the engineering center. He's just like a collator for of all the information and finally putting it forth to the engineering center chief. His role also involves technical management of the entire habitat, be it research as well as other production and manufacturing centers. And he also deals with an administration. He also deals with the administration aspect as well. This guy has the power of communication control as well as management of control. Then we'll be having R&M technicians, repair and maintenance technicians, and there will be research and development astronauts, and there will be manufacturing and workshop technicians as well. Each, depending upon the manpower, further astronauts could be fitted in R&M, R&D, and manufacturing. However, the basic necessity of the organization will be 5 astronauts at the initial stage of development. Well, I would like to pull a piece of information from previous presentation. I guess it's from Mission 46 by Just Purewal from England. She gave a very intuitive feel about the rations which are necessary for astronauts in the due course of their work on planet Mars. So on an average, the food requirement per astronaut would be 0.86 kg per day, and the water consumption will be 2.5 liters per day. Well, 2.5 liters is almost like 2.5 bottles, and that's just not enough for most guys, because an average astronaut he takes about 130 liters of water per month, and that's quite high. Astronauts have to not just sacrifice in terms of their contact with the outer world, but also in terms of the rations available for them to sustain the life. And one more thing, greenhouse plays a very important role in self-sustaining and the food production needs. So engineering center chief doesn't have, engineering center doesn't have a standalone greenhouse. However, in association with greenhouse department as well as with potential stakeholders, assistance for gas assistance or gas filtration assistance for greenhouse setup, that could be assisted by the engineering center. Yes, beyond research and beyond all the technical aspects, living the Martian life and thriving along the Martian land is something that's really important. So in my design, I've made sure that ambience and natural sunlight will always be available in addition to the dome kind of structure which bunkers and all those structures have. So this is what living a real Martian life feels like. And something that's of quite important is that, and this is also again a potential field of research, is that astronauts have a hectic schedule throughout the entire day, and when it comes to proper sleep management, that's something that's really void in most cases. In most cases, earlier astronauts have suffered severe health hazards because of not getting proper sleep. So a proper sleep scheduling tool for the astronauts must be imposed. Even though Martian day and night cycle is synonymous to the just like that of Earth, because of the workload and the potential stress and psychological thing that goes behind, potential sleep mapping must be done for the astronauts. And this is something which me along with my team back in my college worked on. And this is a sleep scheduling tool for astronauts. Basically, it's like based on few questions and suggestive mechanisms from the astronaut to the computer interface, a machine learning and a deep learning model will structure the astronaut's psychology as well as his sleep cycle over a due course of time. And it suggests him appropriate food, nutrition, the amount of sleep which he needs to get, and all the things will be distributed. It's just like a fitness band, but on a more advanced scale, especially for interstellar and deep space travelers. So as you can see over here, we have designed an Arduino setup wherein there will be a hardware solution. So despite the fact of we suggesting the astronauts to sleep for say 6 or 7 hours, it's really important that we need to make them sleep in first place. It's not like they are not willing to sleep, but they just can't sleep because of the stress and pressure. Light therapy is already a proven technology for inducing sleep, especially in terms of astronauts. Right now, at least a few years before before proper light therapy were all introduced, astronauts used to take about 5 times more dosage as humans here, especially people on night shift would take for induction of sleep or either for prevention of sleep. So these medications are really fatal when they use it for a due course of time. So for that, light therapy is a proven technology. Red light of a certain intensity, usually in the visible light range, that's a proven technology. It's tried and tested technology for inducing sleep. When that particular wavelength of light is shielded over your particular eyes, the three phases of sleep, basically the deep sleep as well as the rapid eye movement phase, that will be automatically incorporated upon this particular light therapy. So what basically this setup does is it takes temperature reading as well as it takes a temperature reading from the forehead as well as the pulse reading by aid of a hardware mask, which I'll be very shortly specifying. Yes, this is the hardware solution which we actually thought of. So there will be a temperature reading as well as pulse oximeter connected to the forehead dimple. So based upon that particular information as well as the astronaut's input to the machine learning interface, based upon which a model will be constructed, and depending upon which the intensity of light from the LED will be controlled over the particular eyes. So these are the LEDs which will be actually accommodate over this particular region, and appropriate light therapy can be induced. So how do we know if an astronaut has slept or not? We use tilt sensors basically. So this tilt sensor predicts whether the astronaut is in deep sleep mode or in rapid eye movement, or he is just starting his sleep, and appropriately the intensity of light will again be continued. Well, when it comes to proper functioning, we have to follow certain protocols. Every company, be it manufacturing sector or any other sector for that matter, has protocols. So, in my opinion, we just can't identify, we just can't predict as to how the Martian atmosphere is going to be and how it is going to react towards potential settlements or other centers over there. So, till we try and experience that particular basis, we just can't establish norms in first place. So as of now, just for the sake of protocols for R&D, manufacturing division, repair and maintenance, and control and communication center is established. Well, regarding the safety aspect as well as the training center, there are several other protocols which are eventually necessary. But once after we go there and we try and test the particular uh, um, all the experiences in the Martian atmosphere. So this is a very common method for production as well as for various managements and research. This is called as a V model, and it is quite famous among several industrialists out there. Uh, we have been setting up industry for really a long time. It's been several hundred decades since we established proper functioning industry, and over due course of time, we drafted proper protocols for operation. So this will be the common operation for all the industrial setups, as I've specified here, both R&D, manufacturing, and several other. This will be the common protocol which is to be followed. It all starts with concepts of operation, and depending upon the requirements of the clients and the architecture, potential architecture which we have, we go about doing the detailed designing. And finally, if it is found to be proper, we implement it. Otherwise, it goes through an iterative process of operation and maintenance, and we verify and validate it. So verification and validation is something that's really important, and it's a part and parcel of engineering center. So this is how proper implementation goes about. Now, speaking about what could be the potential learnings for earthlings out there, we have always been pushing up technology, and there are always politicians, Greta and several other environmentalists, etc. They're always there to say to resolve the problems first on Earth before we go to Mars. But actually, the thing is, going to Mars is actually a major problem solver. This is because when we go to Mars, we are not just going there and we are not just implementing the existing technology, but we are actually pushing the technology that could potentially be implemented on planet Earth as well. There will be resource sharing. We are not expanding the population, but rather we are splitting the population. This way, the resource utilization as well as the extent of pollution and several other factors that goes because of over expansion of human beings. So that could very well be curbed. So few technologies that could be implemented is lean sustainable manufacturing, which is nothing but additive manufacturing, and vertical axis wind turbine. For just lean atmosphere in planet Mars, if it is found to be efficient, in planet Earth, it's going to be really efficient. So there can be 3D printed DIY technologies extension. Right now, the 3D printing is something which all of us heard of, but 3D printing is something that's not experimented upon, not on a common scale. It's just like what touch screen phones, how it was just about a decade or two ago. Just like the 3D printing is just an introductory technology. When it is extended to all the public out there, then the true potential could be tapped. You could have designs. You are the creator, and you will be the manufacturer, and you will be the consumer. So this power of manufacturing as well as consumption greatly elevates our requirements as well as our the satisfaction of our requirements. Cosmo Refofile, which is nothing but the sleep assistant deep learning model which we suggested, that could be implemented not just for astronauts out there, but it could also be implemented for shift workers, hospital health workers, especially during this COVID pandemic. You could have seen overnight workers, etc. So this sleep assistant will be a really good solution. And finally, geospatial swarm drone mapping is another prospect. So United Nations have set up 17 major sustainable goals, and by the end of this decade, from 2021 to 2030, by the end of that particular decade, we are expected to elevate the standards of humans in new prospects and attain all the sustainable development goals. So basically, the initiative taken by Habitat Marte as well as the initiative taken by Engineering Center, which is ideated to be set up in Mars, it will be satisfying the following sustainable goals: quality education by means of training center, as I said; affordable and clean energy by means of the solar panels and vertical axis wind turbines; industry and innovation, perhaps by means of 3D printing technologies; sustainable cities. Martian settlement indeed is a sustainable city, and even if you write something, say for instance, if you write something and it turns out to be wrong, you just tear the paper and you throw it in the dustbin. But even that particular resource is proven to be very important, and that's the transportation cost is really costly for that. So we have to live a really sustainable life. Even a garbage is gold in planets such as Mars. I'll explain about the economy which goes behind this real soon. Then responsible consumption, climate action, and finally partnership for the goals. We are going to Mars not just because we can do it, but because we have to do it. And this is not possible because of just a single man's goal. It's not a vision. It's not a vision of a single man, but rather it's a vision of humanity. So collaboration is something that's really important, and 17 Sustainable Development Goals satisfies that aspect. Okay, now take a shampoo bottle. Oh my god, take a bottle of shampoo. So that bottle of shampoo, it costs about $4, or in Indian rupees, depending upon the range of quality. You find it in a few hundreds. So as soon as we utilize a particular shampoo, we just throw the plastic bottle, or rather we give it for recycling. This is how the waste management cycle goes about in planet Earth: utilizing the resource, manufacturing, utilizing, and then waste management. This is a cycle. But This particular bottle of gold, this particular bottle of shampoo, even without the shampoo, could be worth several bricks of gold when it is transported to Mars. How is it so? How can a value be elevated when it is transported to another planet? You might very well be aware, back in those days when transportation was not that much easily available. In those times, what we had was we were just confined to the resources what we were available. As transportation increased, as networking between the countries increased, we had accessible to cheaper resources. If you want to get a product from United States, say for instance Carolina Reaper chips, back in about 1960s or 70s, you just can't get access to it. But right now, with the power of Amazon and all the aerial transportation systems, you could get access to it because of increase in transportation. But Mars has just 2 years window for transportation, and with that particular narrow window, and with all the other costs which brings with alongside with launch vehicle construction cost, manpower cost, fuel cost, astronaut transportation cost, and several other salaries for the workers, the cost is going to be really high. Eventually, rather than depending upon planet Earth for all the resources, these guys should become self-sustainable. Well, that's a long-term goal, but at least during the initial phases of the establishment, we might have to supply them resources, and this is going to be really costly. And cost ultimately, when we speak about exploration, it's not just the science, but ultimately it is the it's not just the zeal that goes, but ultimately it is the business which we speak about. So economic study is something that's really important. Eventually, if an industry is established in that particular colony, and if there are several other habitats scattered around the planet, potential high cost tourism, just a minute, high cost tourism, that could be one potential way of bringing in income. And people, billionaires will always be interested to visit Mars, provided that they have money. And trade across the habitats, these are all some of the ways of economic sustainability. So when we speak about planet, Earth to Mars transportation, resources, parts, manufactured parts, especially something that just can't be manufactured in Mars, and crew and nuclear fuel. These are the resources which we will be needing. So yes, eventually, as we gear towards going Mars, we have this ambition of reaching it in a decade. As we gear towards reaching Mars, we have to solve all the existing issues and finally make a proper systematic plan for reaching the planet Mars. So vision is ours and goal is also ours. That's about it. Thank you guys. And if you guys could would like to explore more on the stated concepts, you could always refer to these resources. There are several other resources which are not specified here, which have not been taken from reputed sources, such as YouTube videos or proper references from CubeSat videos, and there are several other volunteers who are coming up and for open source projects on Mars settlement that could also be referred to. Thank you guys, and these are my details. If you guys wish to contact, you could contact me. Thank you.